A successful game must have a richer gameplay. You need to give users a larger space for exploration so that they can be retained. If it is just a simple fixed-point free throw, users may lose interest after playing for a few minutes. The success of any game is inseparable from the planner's control and speculation of the player's psychology. You must try every means to stimulate the curiosity and challenge of the player. So, we want to allow players to shoot at any position on the basketball court. Then, the first step is to allow players to walk with the ball at any position on the basketball court. Therefore, we first design a joystick and use the offset vector of the joystick cap relative to the center point of the joystick to indicate the direction of the player's movement. First, we import the joystick-related image materials into the project. Right-click in the Resources folder and select Import from folder. Check the materials to be imported and click Import. As for the joystick materials, you can design them yourself, search through search engines, or get them from us. Then, create a new UI in the UI folder. Name it Joystick. Double-click to open. Drag the joystick base image to the scene. Change the node name to left, indicating the left joystick. Set its anchor property to the lower left corner. Adjust its position. Change the color property value to make the joystick semi-transparent. Avoid blocking other objects in the game. Drag the joystick cap node to the left node, and change the node name to cap. Change the scale value and adjust the size of the joystick cap node appropriately. We set its scale value to 0.5 here. Change the color property value of the joystick cap and set it to semi-transparent effect. Press the shortcut key Ctrl+S to save. Go back to the scene window and drag the finished joystick UI to the hierarchy window on the left. Switch to the game window to view the effect. Next, we need to write a script to control the joystick. Create a new TypeScript file in the Scripts folder. Name it Joystick Controller. Drag it to the inspector window on the right side of the joystick node. Double-click the Joystick Controller script to open it. To control the UI, you need to get the UI component on the current node first. Therefore, we first declare a member variable UI component. Then initialize it in the onStart method. Because we need to control the movement of the joystick cap, and when releasing it, we need to pull the joystick cap back to the center of the joystick. Therefore, we declare two variables to record the joystick base image and the joystick cap image. Then initialize it in onStart. First, get the canvas on the UI component. Then search the image child node left through the canvas to get the joystick base. Finally, search the image child node cap through the joystick base to get the joystick cap. To achieve touch control of any position of the joystick base, move the joystick cap to the corresponding position. We need to add event listeners to the joystick base. Two methods are required for processing when touching and releasing the joystick. Add listeners in the onStart method. When touching and dragging, the position of the joystick cap must be updated in real time. When touching and releasing, the joystick cap needs to be pulled back to the starting position. Therefore, it is also necessary to add corresponding listeners in the onStart method for processing. Run and test. It is found that the console has output when touching anywhere on the joystick base. However, when touching on the joystick cap, the console has no output, which does not meet the design. We hope that touching on the joystick cap will also respond. Open the joystick UI. Select the joystick cap node in the inspector window on the right, and check the raycast target property. It means that this UI object cannot be clicked or interact with other rays, that is, it does not accept user events after unchecking. Save and test. It is found that clicking on the joystick cap will also respond. Now, we can realize the position of the joystick cap by touching the joystick. Some students say that this is simple. Get the coordinates of the touch point and set this coordinate to the joystick cap. Let's try it. Why use world coordinates here and local coordinates here? Let's give you a brief explanation. The touch event occurs in the entire screen area, so its coordinate origin is in the upper left corner of the screen. To the right is the positive direction of the x-axis, and downward is the positive direction of the y-axis. Therefore, it is easier to use the method of setting the world coordinates of the joystick cap when we move the joystick cap. Why do we use local coordinates when releasing the joystick? The reason is that the joystick cap is a child node of the joystick, and its anchor point is the center point of the joystick. That is to say, the coordinate origin of the local coordinates of the joystick cap is at the center point of the joystick. Therefore, when resetting, just set the local coordinates of the joystick cap to the 0 vector. Run and test. It seems to be fine. However, have you ever thought about the purpose of designing the joystick? And the joystick should not exceed the corresponding range. What should we do? First, we limit the range of movement of the joystick. We only allow the joystick cap to move within the radius of the joystick. So, we first declare a variable to record the radius of the joystick. Then initialize the radius of the joystick in the onStart method. The radius of the joystick is equal to half the width of the joystick. The purpose of designing the joystick is to obtain the direction vector represented by the joystick cap. Then use it to control the movement of objects in the game. The offset vector of the joystick cap relative to the center point of the joystick base is the direction vector represented by the joystick cap. That is, the purple vector in this picture. We have already obtained the red vector, which is the position in the touch event object. The yellow vector is actually the world coordinate of the center point of the joystick base. We can declare a variable to record the world coordinate of the joystick base and initialize its value in the onStart method. Next, we declare a member variable to record the offset vector of the joystick cap and calculate the value of this vector in the joystick movement processing method. If the joystick cap moves beyond the radius, it will be pulled back to the circumference of the base. Test and find a problem. The reason is that the center position of the joystick is calculated incorrectly. Note that because the reference anchor point of the joystick base is the lower left corner, therefore, the world coordinates obtained are the coordinates of the lower left corner of the joystick base. That is, the coordinates of the lower left corner of the yellow rectangle in this picture, which is obviously not the center point of the joystick. The reference anchor point of the joystick cap is the center point of the joystick base. Therefore, here we need to use the world coordinates of the joystick cap at the beginning to represent the center point of the joystick. In addition, if the screen resolution changes during operation, the joystick will have problems. To solve this problem, we need to recalculate the joystick center point and radius after the touch is released. After the joystick is designed, we can use the joystick to control the movement of the basketball. Because the direction of the joystick needs to be obtained externally to control the direction of the basketball, a method should be provided in the joystick script for external access to the direction of the joystick. One thing to note here is that the joystick controls the movement of the object in the XZ plane. Therefore, we can switch to the top view in the scene window to observe the correspondence between the direction represented by the joystick and the direction of the object's movement. You will find that the x-coordinate direction of the joystick cap offset vector is opposite to the x-coordinate direction in the spatial coordinate system. And the y direction of the joystick cap coordinate system is consistent with the z direction in the spatial coordinate system. Therefore, this method of obtaining the moving direction should return a three-dimensional vector. Double-click the basketball controller script to open it. Add a reference to the joystick and associate the joystick node in the editor. The basketball is in the hold state before it is allowed to move. Therefore, we add the processing logic of moving the basketball in the hold branch. Add a setting for the initial speed of the basketball. Then, implement the control logic of moving the basketball. The basketball movement logic is the current position plus the moving distance. The moving distance is the moving direction multiplied by the moving speed multiplied by the time interval. Change the initial state of the basketball to hold and test it. It is found that the basketball cannot stop after moving. According to the movement logic just now, move direction must not be reset to 0 when the joystick is reset. press and hold the Ctrl key to track the code. It is found that the direction vector represented by the joystick is not reset to 0 after the joystick is released. Reset the joystick direction vector to 0 in the logic of releasing the joystick cap. Save and test. The joystick can control the basketball to move in the horizontal plane normally. But when the basketball moves out of the screen, we can't see it. Therefore, next we need to make the main camera follow the basketball.